Olá! A IUPAP, International Union for Pure and Applied Physics, está interessada em muitas coisas. Dentre elas, a definição das unidades básicas que nós usamos no dia a dia, a manutenção das constantes fundamentais, mas também está muito interessada nos desafios que a ciência tem atualmente. Na área da física são muitos os desafios. Nós temos desafios desde o entendimento das partículas elementares, da matéria condensada, na física nuclear, na biofísica, na astrofísica. Em todas as áreas, ou sub-áreas da física, nós temos desafios. Para que você saiba quais são esses desafios, a IUPAP organizou um workshop especial, que chama-se Entendendo os Desafios da Física Moderna. Cada área da física está aqui sendo apresentada por um líder, membro da IUPAP, e que você terá então agora a chance de entender, através desta apresentação, os desafios que a área apresenta e como os físicos, de um modo geral, estão superando esses desafios para que a física seja um instrumento de entendimento das ciências naturais e que auxilie o homem não apenas a avançar o seu conhecimento, mas a tornar a ciência um instrumento útil da melhoria de vida de cada um existente nesse planeta e nesse universo. Assista e também faça parte do entendimento dos desafios da física moderna. Boa sorte!
Our first talk in this part will be by Sandro Scandolo on Physics for Development.
Thank you, Juan. Thank you everyone for being here in this last part of the day and the workshop. So I'm going to say a few words about the status of physics in developing countries and the role that physics can play for development. But before I do that, I'd like really to thank the members of the C13 committee, whom you see here at the last meeting. We meet regularly every year in Trieste, so this is a picture we took at the last meeting at the end of August. You might recognize Min Song, who's there. He was also here attending the meeting as a member of the delegation. So, first of all, why physics for development? Why do we need a commission? Why do we need to care about physics for development? Well, there are, of course, a number of reasons why we care about physics for development. The first one, of course, is that global challenges have a strong fundamental science component. Think of climate change, for example. Think of the modeling that is required to study climate change. Think of renewable energies, for example, the energy crisis and the role that science, basic science, fundamental science can play in developing new materials for renewable energies. And it is also, the typical example I give is, the consequences of, the causes of climate change are, originate from developed countries, and the effects are going to be stronger in developing countries. So we definitely need to make sure that developing countries are aware of the consequences of climate change, for example, and put in place policies that are, of course, based on science to correct for the consequences of climate change. Another reason, of course, is the ability to focus on regional technologies, focus on regional priorities. Again, as I said before, solar energy may not be a priority for a Scandinavian country, but it's certainly a priority for an African country where sun is abundant in terms of as a natural resource. Physics is also, as we've been discussing over and over at this workshop, is at the basis of most applied disciplines. So you'll never be able to educate an engineer without a strong physics background, a strong mathematics background. So you need physics also because you need teachers, you need lecturers that are able to then teach to whoever then becomes, relevant for in terms of applied technologies and applied disciplines. And then, of course, there is the last argument, which is always a bit difficult I mean, particularly outside of the physics community to convey. And this is the fact that, you know, if there is one resource which is democratically distributed around the world, this is gray matter. This is our brain. I mean, and so scientific thought, I mean, scientific advancement is actually, it is a human right. Article 27 of the Charter of Human Rights lists the opportunity to advance sciences as a human right. There is, however, as we well know, I mean, a sort of physics divide. There is the Western or the Northern or and the Southern, the developing world. And this is reflected also if you just look at the memberships in the IUPAP countries. So you see Africa is only a few countries are members, a few countries in Central America, and a few countries in Southeast Asia. So it's clear that there is a divide when it comes to physics, as well, of course, as in all other fields of society. We are all physicists, right? So we want to quantify this physics divide. So I just took data from several sources. There's actually this beautiful website. I don't know how many of you have seen it. It's called SciMago, where you can find plenty of data about publications, citations, I mean, real data that you can analyze. So this is a distribution of, per continent of the number of papers in all fields and the number of papers in physics in terms of percentages, and compared with the percentage in terms of GDP and population, world population. And as you can see, first of all, you might be surprised at the fact that the percentages don't sum to 100% for the papers, and this is due to the fact that papers are published by international collaborations in a number of cases, so they are counted twice in different continents. But in any case, if you look at, for example, Europe or the US, North America, you see that more or less the percentage of papers reflects the percentage, at least of the GDP, and sometimes exceeds the percentage of population. In the case of China, for example, it's more or less the same percentage of the population. Australia is also doing quite well. South America is really borderline in terms of percentages. It is more or less the same percentage as the GDP of the population. But then you look at Africa, and we are clearly at least an order of magnitude below what is the world average in terms of just products, publications, output of research. Now, we also, of course, are very familiar with the fact that the number of publications may not be the right way to count, to evaluate, to measure what is the scientific output of a country. Well, you might be surprised that, indeed, even for countries, people have come out with H indices. Now, we've been discussing H indices for scientists over and over, whether it's a good index or not. I'm not sure. In any case, it's probably one of the best single-valued indices we can come up with to evaluate the output of a scientist, in this particular case, the output of a country. So this is, well, you can spend hours looking at this table. Let me just perhaps remark that the number of documents is not necessarily the papers, essentially, is not necessarily reflecting the number of citations. There are some notable examples, like, for example, in the case of China, you see there's the number of papers is much higher than the number of citations compared to other countries. Actually, this list is now ranked as a function of the H index. By the way, I find it really remarkable that the US have 1,648 papers that have been cited 1,048 times. It's really amazing. And another column I would like you to note, to take note of, is this citations per document, per paper. And, you know, there are countries for which the citations are on the order of 20. Again, China, as you can see, is 7. So, in other words, I mean, looking at the number of papers is not necessarily a good measure of the output of scientific output of the country. And also you notice that there are some countries like the Netherlands, Switzerland, but also the US, in which the number of citations per paper is you know, it's higher than in other countries. We're talking about papers divides. There's also a citations divide, of course. When you look at the citations, as this is now physics, so here it is, when I'm showing here, is how many times physics papers from a given country have been cited in year 2016. I've chosen 5 countries in Asia, just, I mean, randomly. Of course, I've chosen China, and you see, and we are at the order of 70,000 citations for physics papers in China in 2016. Singapore is also doing quite well in terms of, compared to the size and the GDP of the country. And you can see this, what is really depressing, I guess, is the fact that there are still countries like Myanmar, Burma, in which only one citation in the entire year for a physics paper coming from, with the authorship from Burma. And I actually put myself, I'm not a top scientist, I'm an average scientist like many of you. I'm not, the purpose of this is not to show how good I am, the purpose is to show that even an average scientist like me, the number of citations is more or less like that of an average Asian country. Let me go to Africa now. Again, you find all this data from this website, if you wish. And even here, the situation is quite, I would call it dramatic for a number of reasons, right? So this is the number of papers. This is the papers published in about 20 years, from 1996 to 2014. You don't see Egypt, because Egypt in this particular website is listed as a Middle Eastern country. Sorry about that. You see, this is now publications and citations in physics, specifically in physics. Again, if you look at the citations per document, well, this is not really particularly high. South Africa, of course, does quite well. There is actually an exception here, Namibia. Namibia, I actually looked at the details of Namibia. This is because Namibia participates in the HES international program. And so there are a number of good papers coming from international collaborations through this collaboration. In fact, this is perhaps one of the messages that one can take out of these tables. International cooperation is one way to increase the level of science in a given country. Also, I mean, if you compare the H indices, so these are the country H indices, okay? Say, in Kenya, what is Kenya? I can see it from there, I can see it here, 24. So that means that only 24 papers published by Kenyan physicists in the last 20 years have been cited more than 24 times. Again, I'm an average scientist, my H index is 38. Well, I would probably be somewhere here. So my H index, the single person, single scientist, is higher than that of essentially most African countries, except probably the first 5 or 6. And again, if you look at the numbers in terms of citation, I've chosen France just because the president-elect is from France. France in a given year has 300,000, sorry, in the same time range, sorry, has 300,000 publications, and this is the number of citations, just to give you an example, I mean, a comparison to understand. Now, of course, we know what the problem is. Scientific output is directly proportional to spending in research and development. So this is a plot that shows the number of citations. This is actually in all fields of all disciplines, not just physics. Citations in all fields as a function of spending in research and development. It was actually difficult to find data for research and development spending for all countries. But I mean, in fact, this is a subset of the countries, only those for which these data are available. And of course, you see there is a very nice correlation. The more you spend on research and development, of course, the higher is the scientific output of a country. So this is an important take-home message, I mean, for those of you who go back to your own country and discuss with your policymakers. But of course, there are exceptions, right? There are exceptions. There are countries that outperform, like the UK, like Greece, surprisingly. Iran, for the same spending in research and development, Iran, for example, has an output which is an order of magnitude higher than that of other countries. And there are also low performance, like those that you see here, which spend a lot of money in research and development for a limited output. Now, by the way, if you consider scientific output citations, right, we like to measure scientific output in terms of citations, right? So the value we assign to scientific output is, for most of us, at least physicists, is how many citations you get. Of course, there's much more than that. There's number of PhDs, there is patents, those of you who produce patents, so there's much more than that. But if you consider scientific output only citations, this linear relationship, you can take a fit of this, and what you obtain is that is the cost of one citation, that is, the amount of research and development R&D spending that you have to put in order to obtain one single citation is $50,000. Amazing, isn't it? next time you publish a paper and you add a citation to your paper, you're adding the value of the country that you're citing by an amount which is $50,000. Of course, without considering that scientific output is much more than just citations. There's much more than that. So this is just pure curiosity in some sense. Now, there's also the education divide, the PhD divide. There's not just papers, not just scientific output, but also how we educate the new generations. Let me just mention there are a number of countries, there are many more probably that I'm not aware of, but certainly these countries here don't have a PhD program in physics yet. So how can we think of, developing physics in those countries if there is not even a PhD program in those countries? In fact, it is, nice to see that, in fact, the consortium of universities in the Central America have actually decided to work together, together with other countries where PhD programs exist, and support the development of PhD programs also in other countries. Africa is also this. Actually, this is a result of a study, of a survey that the APS has started with Jim Gubernatis, led by Jim Gubernatis, in partnership also with other organizations, the Institute of Physics, the EPS, ICTP, and other African partners. So this is the number of PhDs in physics in 1 year. And as you can see, the numbers are, by the way, there is no evidence there are PhDs in the other countries. And it's easy, the comparison with the number of PhDs in the US is also quite, striking. The total number of PhDs in physics in the whole Africa probably is of the order of 300, 400. Here, the data for Nigeria is not there. Nigeria produces a large number of PhDs in physics. So it's probably of the order of a couple of hundred, 200. Brazil, we've heard the first day, it's 1 PhD per day. So a single country in Latin America produces more PhDs in physics than the whole of Africa. Now, there is also, let's try to now be a bit more optimistic, okay? There are efforts. There are efforts that, as, for example, C13 has been trying to push forward, but many other organizations are following up. This, I guess, is one of the most successful operations in the last few years. It's the organization of schools. These are both biannual schools, one on more fundamental aspects, the other one on more condensed matter physics, material science aspects. They have taken place in a number of countries on a rotation basis. And they've been quite successful. The success, I guess, can be measured by the number of other organizations that have been supporting these programs, also financially. And I guess the reason why they've been successful is that they focus heavily on mentorship, on community building and networking with the international community. In particular, I'm very familiar with this one, which is the one on electronic structure, methods, and application. And we've essentially now have past students participating as mentors or as lecturers in the new schools that come. So we're trying to create a community with a long-term effort. Another important aspect is to recognize excellence, right? And I guess the example that we've set with the establishment of the C13 medal is an important one. Well, I don't need to go into the details. You may remember that we've assigned the C13 medal for outstanding contributions to the advancement of physics in developing countries to Professor Flores Valdez at this General Assembly. But there are other examples of prizes that recognize excellence in the developing world. The ICTP, the institution where I come from, by the way, awards annually a prize to a young physicist from a developing country. This is, for example, the winner of the 2013 prize. Here the prize is given by the UNESCO Director General, Irina Bokova, former, by the way. There's a new one as of a couple of hours ago. This is also an award that has been promoted by the African Union. It's called the Nkrumah Science Award, and it's this is for all sciences. In 2014, Timoleon Kofane from Cameroon has received the award. Actually, it's a very prestigious award at the continental level. Sorry. Of course, we don't have to forget that the issues that are important for the whole international community are as important, if not even more important, when it comes to developing countries. We've had nice presentations by Eagle and others in this meeting, so I don't need to go into the details of that. But of course, the problem of gender is extremely important in developing countries. It's probably compounded with the fact that in developing countries there are traditions, cultural boundary conditions that make the problem sometimes even more dramatic and more difficult. I just wanted to mention perhaps this organization that is based in Trieste and has received recently substantial support, financial support from funding agencies to run programs like fellowship, networking, and awards. Of course, this is in the whole sciences, but of course physics is included as well. Let me just spend 2 words about the institution where I come from, the ICTP, International Center for Theoretical Physics, a UNESCO institute whose mission is precisely to support science, physics, and mathematics in developing countries. Before I do that, actually, let me mention that in 1984, the IUPAP General Assembly met in Trieste at the ICTP. So I was browsing, I was Googling this, and I found this interesting document that shows the resolutions that were approved at that conference. If you can read it, it's actually, the first one is particularly nice. The resolution is that Andrei Sakharov be re-established, be given the possibility to re-establish communication with his scientific colleagues around the world, right? Another one is this worry that about the increase of acoustic pollution. Okay, I wonder whether the word has changed since 30 years from now. This is the picture of the IUPAP General Assembly in 1984 that met in Trieste. So, what is ICTP? ICTP is again a UNESCO institute. It was founded by Abdus Salam, Nobel Prize for Physics. And he was actually director of the center for many years. We ran a program of schools, conferences, and workshops, and we support the participation of participants and students, and also senior participants from developing countries. We do research because we believe that it is important that scientists run programs in support of their colleagues in developing countries. We have a number of postgraduate programs and also have a number of programs that support career development. This is just in a nutshell the numbers that we had throughout the history of the ICTP in the last 40 years, at least 50 years. So this is the number of visitor scientists that came to the ICTP, and as you can see, there is a perfect balance between different geographical areas. And if there is an imbalance here, Europe and perhaps a little bit of North America, you have to consider that these scientists from those countries, they're not supported financially. So if they come because the level of the activity is sufficiently high. So this is for us actually a measure of the quality of the programs. Just briefly, the news about the ICTP is that Trieste is small for us, and so we've been trying to create centers, partner institutes around the world. This is the list of the partner institutes we are creating. There's the one in Rwanda, which is going to be inaugurated soon, where we're going to run a master's program in physics. And let me just say a few words about the one in Brazil, since we are here, the host country. We actually heard that the representative of the Brazilian Physical Society is a deputy director of this institute. So it's been running now for about 5 years, and it's a truly international center. So you see they have about 800 international students from both from within Latin America and from outside of Latin America. And it's been, UNESCO has been considered as the top in the list of Latin American institutions according to this Nature Index, primarily thanks to the ICTP partner institute there. And it is a Category 2 institute of UNESCO. Category 2 means that it is funded by the local governments, local sources, but it becomes somehow affiliated to UNESCO, which guarantees the international nature of the institute. Finally, I'd like to spend a few words about an idea, a concept that has become quite, relevant when it comes to international cooperation, particularly with developing countries, which is the concept of science diplomacy. And of course, we've heard about Sesame before. I showed you a couple of slides about Sesame. This is a beautiful example of science diplomacy, how science brings around the same table countries that wouldn't be otherwise talking to each other. But let me give you another example, which is taken from facts that took place last year. You remember the Iran deal. So Kerry and Zarif, they met and they finally, well, now unfortunately we are probably on the verge of having to reconsider this deal. But anyway, at the time it was considered as a success. But what probably not many of you might remember is that this deal was actually made possible by the fact that their advisors were actually nuclear physicists. And in fact, perhaps even more strikingly, this was made possible because the two were actually spending time together at MIT at the same time, when Moniz was a postdoc and Salehi was a student at MIT. So they knew each other. They had collaborated as physicists in many years before. So I think this is a very beautiful example of how, you know, science, physics can be a common language that we all share. And let me just conclude by again quoting Abdus Salam, who used to say that you know, we can be divided because of our political ideas, religious ideas, but when we're in front of a mathematical equation, we all agree. Thank you very much.
Thank you very much for this very interesting talk. So we open now for some questions to the audience. Comments? One? Bruce?
Thank you very much, Sandro, for a beautiful talk. When you dig into those statistics and citations per paper over that 20-year period, one country really stands out, the one with the most citations per paper. It's not on your list. And I don't think anyone in the room would guess which country it is.
In terms of, you mean China?
No. The one with, it's not on your list. It's way down in terms of total number of papers.
Okay.
It's the Faroe Islands.
It's what, sorry?
The Faroe Islands.
Oh, I see.
In the North Atlantic.
Okay. I guess
it's way down on that list because the total number of papers in that 20-year period is 6.
Mm-hmm.
One of those papers has 600 citations. So the number of citations per paper is 100, way bigger than any number you have up there.
Okay, thank you, Bruce. I think we're reaching the limit of, statistical noise at that point, unfortunately. But
okay, there is another question.
Right, Sandro. I'm wondering whether the budget cuts in the Brazilian, in Brazil would contribute to, would affect the activities of the ICTP in Brazil.
Oh, okay. Thank you for the question. You probably asked the question to them. As far as I understand, not yet. In the sense that the commitment of the funding agencies, in particular the state of São Paulo, you have to consider that the main agency that funds the center is the state of São Paulo. It's not the federal government, it's the state of São Paulo. Now, of course, the budget will be decreased, but thanks to the fact that the government had to sign an agreement with UNESCO, the government has to fulfill an international obligation. So this, in some sense, makes the whole thing a little bit less, more resistant, more resilient to funding cuts.
On this diagram, there's always a question of causality. Is it the fact that there's a lot of scientific impact, which means that there's a high R&D spend?
Yes, of course. I mean, the correlation is not causality. Seen from my perspective, this is a good argument when I approach policymakers, of course, but policymakers could make the opposite argument with me. Yes, I am clearly, yeah. I guess it also depends on how open-minded are policymakers. And the more a country is investing in producing scientific output, the more it is likely that the country has policymakers which understand the importance of science.
Okay, thank you, Sandro. So I don't see more comments or questions, so we thank Sandro again.